Bismillahirrahmanirrahim. This is our sixth lab in which we are going to detect the buildings using the high resolution imagery as well as the elevation dataset. And now in this lab we will follow a timeline as we will see an introduction to rule set development, which is basically a continuity of the previous lab, and we will understand a big picture of building extraction. Then we will be performing rule-based classification using imagery as well as digital surface model or digital elevation model, whatsoever data we will have. And then we will develop a strategy that how to delineate buildings properly. And we will export the result and will perform some minor post-processing in ArcMap. And then we will be finally concluding our lab session. Now, as a first step, what we have to do is to add our data set. We can add our data set by pressing the control and selecting the available data set. I have here DSM and an RGB image. So I will press control and select both of them and click OK. Here I have four layers now. First one is my DSM layer. So I will rename it as DSM. And then I have RGB, that is red, and the second one is green, and the third one is blue. So I have three layers over here and one DSM layer. Once you have renamed the layer, you just have to click OK. Your data set will be added over. Once you have your data set loaded, you can go to the layer mixing and just check DSM and uncheck all the others. So here you have a DSM layer, right? Important thing to note is here you have buildings and here you have trees, right? So we will differentiate between buildings and trees later. Go to layer mixing again and select as natural color RGB and click OK. Now you can see a very good representation of the study area. Now to detect building, we must note down, this is a document that I have downloaded from eCognition official website tutorials. Now in this document it says that the spectral information about building, it is usually inconsistent, right? So buildings, they have different shape and size, and they can be rectangular, circular, and they have a shadow, they have the height information, they have the spectral information, right? So for buildings, they have the usually have the higher elevation than their surrounding. In addition, there is a very steep slope at the edge of the building, so the elevation changes suddenly. So these information, they are usually used. The elevation information, the spectral information, the shape and size of the building information, these information actually are used to detect the buildings. Now as a first step, we have to go to process tree, and in the process tree we have to select append new, and let's name it as building detection algorithm, and uncheck the automatic and click OK. Here we have building detection algorithm. Now in this, click insert child and select multi-resolution segmentation 0.1 and select the scale parameter of 25 and execute it. You can change the shape and compactness based on the concept of the first 5 labs. Now once the result is completed, you have to again insert child. Now in this section, select the spectral difference segmentation and select 15 value for the maximum spectral difference and click execute. Now here I have the output. Now the next thing you have to do is to go to the classification and create class by clicking on the insert class and just rename it as buildings and assign buildings some color of your choice and click OK. Now we have run two algorithms, multi-resolution and spectral difference, and then we have made classes of buildings in class hierarchy. Now the next thing is to go to the image object information. Now this window is going to appear here. Now here what you have to do is to select which features you want to display. For example, here geometry extent is already selected, so you can browse here by going to the layer value and mean. So you will see that all the mean values of all bands and DSM is selected. Similarly, you can use the standard deviation of DSM, that is very important parameter, right? And you can use the other option as length to width extent, right? And similarly, if you want to use some more options, you can just, you have to select all these options and click OK. Once you have selected OK, now whatsoever feature you will click, it will have the blue, green, DSM, green, standard deviation of DSM, all these values displayed. Now the next phase is to select different objects and note down their values. For example, for DSM, you will notice that by clicking on building, I am getting a value that is greater than 760 for buildings, right? And if you click on trees, they maybe have some mixture at 764. So we will use some threshold here. For example, this building has 799 value, 796, 767, here it is 796. So above 765 we have buildings. Now what we have to do is to uh, click insert child. Here you have to select the algorithm of assign class, and in assign class you have to define your threshold. Now the threshold which we want to use is DSM, and that DSM is greater than or equal to 765. Just have to click OK. Now class filter is none, and it will assign to the class buildings, and just click execute. Now once once the process has been completed, you can go to view layer or view classification tab. In view classification tab, what you have to do is to make transparent, not transparent. So here you can see that all these buildings, they are detected properly, and here you will notice that in some cases other features, they may be mixed as well. So let's notice it again and view that. So here you can see that this grass or this vegetation has been included in building, right? So we have to refine our result. Now in order to refine the result, I have inserted another child, and if you see it that I have selected the algorithm of assign class, and have made a threshold condition that my standard deviation of DSM, that should be greater than or equal to 6, right? And from buildings, assign these values to the unclassified. So you just have to click execute. Now you can see that our result has been improved. These vegetation areas, now they are not included in the building section. Similarly, you can further improve your result, but till the part of this lab, we will stop here and export the result in the for post processing. So you have to click select the export, and have to select the export result. Here you have to specify your buildings you want to export, and you have to select the object feature, class related feature relationship to the classification, and here you have to select the class name. Now select OK, and just click export. Now here I am saving this my shapefile in this folder, and click OK. Now once the process has been completed, you just have to open QGIS or ArcMap software, and in that software we will post process our these buildings. Now once your ArcMap software has been opened up, you just have to click add data, connect your folder, and here we have the building shape file. You just have to add this file. Now these are the buildings which are detected. Now in ArcMap, we have to note down different tools which are helpful for post processing. One of them is generalization. You just have to search generalization, and here you will have generalized editing tool. This is a tool that must be kept in mind while performing post processing. And the second tool is simplification. So here we have simplify buildings cartography tool. So this is the tool that is used for the post processing. Two tools, and the third tool, that is common editing tool, right? You have to start editing, and in start editing you have to select the create features buildings, right? Now here you have to simply, for example, this and this, these two roofs, they are part of one building. So what you have to do is to press control and select two. By pressing shift, you will select the two and select the merge option, so that will merge the two polygons which were separate into one. So, and similarly you can use edit vertices, you can use reshape tool, and you can use the cut polygon tool to simplify your buildings. Now as a last part, what you have to if you can add the imagery, right, RGB imagery which we have been provided, if you can add that, so here you can have a clear result that which parts are building and which are not. For example, these polygons, they are not buildings, right? So it is very easy just to uh, simply drag and press delete from the keyboard to delete the unusual polygons. For example, these are not buildings, or maybe there are some parking lots, right? So you can just select them and delete them. Once the you can perform the merging and deleting your buildings, they will be processed properly. Then you can perform other operations, for example change detection or area calculation, etc. So this is the basic lab in which we first started with the data input, then we used the DEM. First we made a rule that is mean DSM greater than 760, they are buildings. Then we improved our result with standard deviation of DSM greater than 6, from building class was moved to the unclassified class, right? So our buildings were improved. Then we opened that result in ArcMap and further improved our result by merging, deleting the objects, and performing some techniques, right? So this is the basic of the building detection and its post processing. You have to practice yourself up and get familiar with all these concepts and practices.